Hello students, welcome to CREATA classes. I am Gurmeet Singh and also welcome to our series on areas related to circles. In this series, we will cover all these lectures using the power of animation and the visualization. The link to all the lectures are given in the description. Check it out. Apart from all this lecture, we are also having the formula list and the quizzes. The PDF of the formula and the concept list will help you to brush up the concept, and the quizzes will help you to check your preparation, the level of preparation before the exam. Check the link in the description. In this lecture, we will cover the revision or the summary of the complete series. So without taking any further time, let's start with this lecture and best of luck. Here it is. This is a circle and this is a sector. Sector is the region between the two radius and the arc. The area of the sector of angle theta is theta upon 360 into pi r square. Here theta is this angle and r is the radius. Further, AB is the arc. AB is a portion of the complete circumference of the circle. The length of the arc AB for angle theta is theta upon 360 degree into 2 pi r. 2 pi r is the complete circumference of the circle, and for theta, the length of the arc AB is theta upon 360 degree into 2 pi r. Further, this is a segment. Segment is a region between the chord and the arc. Here AB is the chord. So the region between the chord and the arc is the segment. We do not have a special formula to find the area of the segment, but we can calculate the area of the segment using the sector and the triangle. So area of the segment is equal to area of the complete sector minus area of the triangle. This way we can calculate the area of the segment. Applying all this formula is very easy. If you know the formula, you can easily apply and solve the question. The trick applies in finding the area of the triangle. I will discuss 2 to 3 different cases in which I will explain how to find the area of the triangle. Let's take the first case. In the first case, we will draw a perpendicular OM toward the chord AB. OM is perpendicular to AB. Here we will use the property of the chord. Whenever we draw a perpendicular bisector of the chord, it will pass through the center of the circle. It means OM is the perpendicular bisector of the chord AB. That is the property of the chord and the circle. Here this angle will be a 90-degree angle, and point M is the midpoint of the chord AB, that is AM and MB both will be equal to each other. The benefit is that once we got OM and AB as perpendicular to each other, we got two triangles, and these two triangles are right angle triangle. It means you can apply the Pythagoras or you can apply the trigonometric ratios to find the missing dimensions or the missing sides. Further, this OM is also the angle bisector of angle O. How? Here if you observe these two triangles are congruent to each other. OM is common in both the triangle, and AM and MB both are equal as M is the midpoint, and OA and OB both are radius. So all the three sides are equal in both the triangle. So we can say by SSS criteria, both the triangles are congruent to each other. Once we got the two triangles as congruent, all the corresponding angles will be equal by CPCT. So these two angles will be equal to each other. Whatever the angle is given in the question, you can split that angle into two equal parts. Suppose this angle is 120, then both angles will be equal to 60 degree. Two benefits we got. First, we got both the triangles as a right angle triangle. Second benefit, we got this angle will help us to apply the trigonometric ratio. You can either take this angle as a trigonometric angle or either this angle as trigonometric angle. You know two angles, you can apply the sum property of the triangle to find the third angle. So this is the first case in which OM is perpendicular to AB. Got it? Students, an important thing for you, check the description for the PDF of the complete formula list and also the link to the quiz. Use the formula list to brush up the concept before the exam and the quizzes to check your preparation before the exam. The link to both the formula list and the quizzes are given in the description. Check it out. So let's back to the lecture. Second case. In the second case, our angle theta is 60 degree. This angle is 60 degree. Whenever you got this angle as 60 degree, then the triangle will be an equilateral triangle. I will show you how. These two sides are the radius. It means these two sides are equal to each other, And we know the property of a triangle, that is angles opposite to equal sides are equal. These two sides are equal, it means these two angles will be equal to each other. For the time being, let's assume both the angle as angle x, both are equal. And we also know the sum property of the triangle, that is sum of all the three angles of a triangle is equal to 180 degree. Let's apply the same property. We got 60 degree plus x is equal to 180 degree. On solving, we got angle x as 60 degree. That is, these two angles are 60 degree. And the third angle which is given one is already an 60 degree. It means all the three angles are equal to each other. So this triangle is an equilateral triangle. Whenever you got this angle as 60 degree, you can directly take the triangle as an equilateral triangle. Once you got the equilateral triangle, you can directly apply the area of the equilateral triangle formula, that is root 3 by 4 a square, where a is the side of the triangle, which are equal. All the three sides are equal. The radius will be the side of the equilateral triangle. This way you can find the area of the triangle. The third case, when this angle is a 90 degree angle. When this angle is 90 degree angle, then the complete triangle itself is an right angle triangle. This is base and this is height. So you can directly apply the formula of area of the triangle, that is half into base into height. Half into r, where r is the radius. By this way you can get the area of the triangle. So we have discussed the three cases to find the area of the triangle. Got it? Let's move further. In the questions, many times the angle theta is not given, but various sectors are given in the question, either in the given figure or you have to draw the sectors yourself based on the data given in the question. Once you got the sectors, the complete revolution of angle around the center is 360 degree, and whatever number of sectors you are having, just divide 360 by the number of the sectors, you will get the angle theta. Suppose in this case we are having 6 sectors, and the angle 360, the complete revolution, the angle 360 is divided into these 6 sectors. So we got angle theta as 360 upon 6, that is 60 degree. Further, once you got the angle theta, you can apply rest of the formulas as we have discussed. Got it? So students, we have done with this lecture. Hope you have enjoyed the lecture. If so, like, subscribe and share this lecture. And do not forget to check out the PDF of the complete formula list and also the link to the various quizzes. The link is in the description. So best of luck for the exam you are preparing for. Bye for now and have a great day.